In this video we're going to be looking at an algorithm that allows us to sort a set of elements. This algorithm is called insertion sort. The basic idea behind it is that suppose you're looking at an array of multiple elements and you are trying to sort these elements, suppose they were numbers, and you're trying to sort them in increasing order. So what you're going to do, the basic idea behind it is that you're going to examine every single element of this array. And suppose you were examining this one, you're going to assume that all the elements preceding it, all the elements preceding that element that you're looking at that moment, are correctly sorted. And then you're going to take your element and place it in the right position with respect to these elements that are correctly sorted. So if we were looking at this particular element, then what we're going to do is we're going to compare it to this one that comes before it. And if that one is larger than our element that we're looking at, then all we're going to have to do is just shift to the right and then compare this one to that one. We'll do that until we find an element that is smaller than the element we're looking at. And this means that suppose we were looking at that one then, and it turns out that this element is smaller than that one. Then what we have to do is just simply insert our particular element right here. And so we're done with this. So these are all going to be sorted now. So we jump from an array of 3 elements being sorted to 4. And we keep on doing this, and then we shift our pointer to this one. And then we look at this element, and then we place it in the right position with respect to the 4 preceding it that are correctly sorted. So the way it would work is that we would first start with the first element here. Of course, this first element is correctly sorted with respect to whatever comes before it. There's nothing that comes before it. So usually we just skip the first element. We go to the second one. Now we look at this one. Actually, let's take a concrete example. So suppose we're looking at that one. So we're looking at number 4 and we're trying to sort this array in increasing order. We look at number 4. We compare it to the number right before it. It's 5. Therefore 5 has to be shifted to the right and 4 comes in its place. So 4 comes here and 5 comes here. Keep on doing this. So now we look at number 6 right here. We compare it to the one before it. 6 compared to 5. 6 is larger than 5. So these are correctly sorted right now. We have this guarantee because we've done it before. We've already looked at these elements with our algorithm. So now we're right here. 6 compared to 5. 6 is larger than 5, so it stays like it is. 6 compared to 4. 6 is larger than 4, so it stays like it is. So 6 in the right position because we have reached the end of the start of the array. We keep on doing this. So for example, suppose now we're going to go to 7, and 7 is going to stay there. 10 is going to stay there. We get to 1. And 1, you're going to compare it to everything before it. And as you can see here, they're all correctly sorted because we already had our pass of the insertion algorithm over it. Now we have this last element. We look at 1. 1 compared to 10, of course 10 is larger. So you're going to shift 10 to the right, and this is going to become a free space. So your 10 is gone here, it comes here. And your 1 is still, you're holding on your 1. You're trying to find the right position to place it into. Then you compare your 1 to 7. Of course 7 is larger, so 7 is going to leave the spot and it's going to be shifted to the right. And now you're still holding on to your 1. Keep on doing this until you find the right position, and you will find that you're going to keep on shifting these numbers until you get 4, 5, 6, and your 1 will of course stop here. So now we have an array that's correctly sorted. This is basically the pseudocode for the array, the insertion sort algorithm. So it's saying we're looking at all the elements from 1. So the elements are indexed in this manner. So it starts at 0 up until n minus 1, where n is the number of elements that we have. Okay. So we look at the first one. Like as we said, 0 actually doesn't have anything to compare with because there's no elements before it. So we usually start at 1. So you go from 1 to n minus 1 with that pointer of yours. Okay. And you're going to be examining each single element of these, and you're going to be executing this algorithm over them. So first you're going to store that element. You're going to hold on to it like we did here with 1. You're going to hold on to it into a temporary variable. So you're going to take it out into a temporary variable. And we're going to stop this right now, and we're going to continue in our next video.